Good evening, students, and welcome to the live Ahaguru session for class 11. Today, we are going to continue with the chapter that we started last class, which is circles. Okay, and I had said last class to finish going through skill builder 1. Okay, that is the basic ideas in circles, equation of a circle, intercepts, okay, special circles, etc., equation of a circle when endpoints of a diameter are given and all that. That skill builder is very, very important. That is the basis for many of the questions that you're going to be looking at. Then I also said once you finish skill builder 1, I'd asked you to look at skill builder 3, which was, so skill builder 1 was equation of a circle. Skill builder 2, which is entirely on tangents. Okay, we have not assigned it because tangents has been removed from the portions. Okay, so 2 circles. So this is what is skill builder 3. Some of the portion in skill builder 3 also concerns about common tangents, etc., which is also been removed from the portions. Okay. Okay. Now what we are going to continue is where we left from last class. Just give me a moment. Just give me 1 second. Looks like there is some problem. Okay, let's continue where we left last class. Sorry, there's some seems to be some issue. Okay, so we are done till question 8. Now the new idea that we are going to learn that we did not do last class is parametric form of the equation of a circle. So here the idea is if you have a circle, let's say with origin as center, then any point on the circle, okay, so let's say is x comma y, you can write that point. If the angle made here is theta, x is r cos theta, y is r sin theta. In fact, this is how we defined cos theta and sin theta for general theta. So here r is the distance, the radius, which is the distance from O to P. Okay. Now, so the parametric form is r cos theta, r sin theta, or a cos theta, a sin theta if a is the radius. So this idea can be extended to any circle. That means the general circle, okay, where, so this is your x-axis and y-axis, and you can still say that this is the theta. That means the theta is the angle made with the positive x-axis, and if instead of origin you call it as center h comma k, then you can say that x is h plus r cos theta and y is k plus r sin theta. So this is the big idea. Okay, and that is what is given in the parametric form. So if you have an equation of the form x is 5 plus 2 cos theta and y is minus 7 plus 2 sin theta, you know what is h, what is k, and what is r. And therefore, you can find the equation of the circle, okay, as x minus h whole squared plus y minus k whole squared is equal to r squared. So the idea is, given the equation of a circle, you can go to parametric form. And given the parametric form, you can go to equation of the circle. That is the idea. Okay. So please go ahead and do question 9, which is a direct application of this idea. Please go and solve question 9. Okay. So this, well, it's a direct application in the sense that you can find the equation of the circle directly. After that, you will have to figure out which of the options is correct. Okay, a few people are still struggling. Okay, I'll give you a couple of more minutes. Okay, so we find that quite a few have answered it now. Okay, so here we have the equation is, so h is 2, k is 3, and r is 3. So x minus 2 whole squared plus y minus 3 whole squared is equal to 3 squared, which is x squared plus y squared minus 4x minus 6y, sorry, not 6x, plus 4 equals 0. Now, so what is its x-axis, y-axis, whether it touches x-axis, y-axis, x-intercept, etc. How do we find out? Well, g is minus 2, f is minus 3, because h comma k is 2 comma 3, which is the same as minus g minus f. Okay, and c is 4. So we know if g square is equal to c. Okay, okay, we saw it in the theory. Did I give it in the theory? Just give me a moment. Okay, so we said circle touches the x-axis if g square equals c, and touches the y-axis if f square is equal to c. Okay, sorry. So this is what we have learned in special circles. So circle touches the x-axis. So here, so, well, does it touch the x-axis at 2 comma 0? Let's see that. So the center is 2 comma 3 and the radius is 3. So the circle is going to be like this. Okay, why did I draw it like this? Because if this is 2 comma 3, so this is 3, this is 3. So that means it touches the x-axis at 2 comma 0. Okay, so the correct answer is option A. Okay, okay, so the next couple of questions, it looks like we are done already. Okay, 10 and 11 we have done. So let's now move on to question 12. Okay. So here we have to, okay. So before we go into that, okay, if you want to look at chords of a circle, okay, any circle, and we did this last class, if you have a chord AB, then you know that the perpendicular from the center to the chord bisects the chord. And this is the most important idea, that if you draw a perpendicular CD, then AD is equal to DB. That means these two are equal. So with this knowledge, you will be able to find things related to chords of a circle. And question 12 also is going to be solved based on this idea. So we have to find the equation of the chord whose midpoint is the origin for question 12. Please go ahead and use this. Okay, so the two ideas required here. One is actually this is the only thing you probably need. Okay, please go ahead and solve question 12. Okay, so here again we have a circle whose center, okay, so let's see, center is -4, 3. That means the origin is somewhere here. So first let's put okay. So this is the origin and this is the center. So we want to find the equation of this chord. Okay. And what is its main property? If you draw a perpendicular from the center to the chord, it will bisect the chord. Okay. So that means if the chord is AB, OC, so let AB be the chord. So OC perpendicular to AB. This is the big idea. Now O0, 0. So MOC is equal to -4/3, which means MAB is equal to 3/4. So equation of AB is y is equal to 3/4x. So 3x minus 4y is 0. It's a line passing to the origin. So therefore, it is of the form y equals mx. Oh, sorry, center is -4. Sorry, -3/4. Okay, so therefore, this is 4/3. My bad. So therefore, this is y equals 4/3x or 4x minus 3y is 0. Sorry. Okay, there are no multiple options here, right? So the answer is 4x minus 3y is equal to 0. See, here it's a very straightforward thing, but for any circle and any midpoint, you can, for any circle, if midpoint of chord is given, we can find its equation. Okay, question 13, again we have finished. Question 14 is also about chords. Okay, but it's a slightly tricky question, so I'll let you take a shot at it for a couple of minutes, then after that I'll give you a hint. Okay, so let's understand what's happening in this question. It's a, as you might have guessed, it's a JEE main question. It's a locus question, and locus questions are generally difficult. Okay, so you have a circle whose center is 4 comma 5. Okay, and radius is 2. Okay, so the circle is like this. Okay, and radius is 2. Okay, chords which subtend an angle theta 1 at the center. So if this is a chord which subtends an angle theta 1 at the center, means okay, the locus of the midpoints of the chords. So if this is a chord AB, it subtends theta 1 at the center. Another chord with this midpoint will also subtend theta 1 at the center if this is the midpoint. So actually this entire thing, if you collect all the points, it's a circle. Okay, locus is a circle C1 of radius R1 subtending theta 1 at the center C. Sorry, locus is a circle, not C1. It's a circle of radius R1. Theta 1 at the center of the circle. Okay, so the question is, if the angle subtended, so what is the radius of this circle? Equals R1, and that R1 is nothing but, if you connect C to this, CD is R1. This is the big idea. And what is the value of CD? That's what you will have to figure out. Okay, a few people have got it now. Others who were not able to do. So what is the connection between R1 and theta 1? How is R1? That is the same way in which R2 will be related to theta 2, R3 will be related to theta 3. Okay, quite a few people have got it by now. So let's look at this. See, it's a fairly simple this thing. The radius of the original circle C1 is 2. So this is 2. 2 cos theta 1 by 2 is R1. That's all. So R2 is 2 cos theta 2 by 2. R3 is 2 cos theta 3 by 2. Now what we are given is theta 1 is pi by 3. So R1 is 2 cos pi by 6. Okay, theta 3 is 2 pi by 3. R3 is 2 cos pi by 3. R2 is 2 cos theta 2 by 2. We don't know R2, we don't know. R2 squared is R1 squared R3 squared. So cos of theta 2 by 2 the whole squared is equal to R1 squared. This is, so 2 squared. 2 squared you can take common. Okay, into cos pi by 6 is root 3 by 2. So 3 by 4 and minus 1 by 4. So cos squared theta 2 by 2 is equal to 1 by 2. So cos theta 2 by 2 is 1 by root 2, which means theta 2 by 2 is pi by 4, which means theta 2 is pi by 2. So the correct answer is option D, pi by 2. Okay, so let's pause here. Let's check if there are any doubts so far. Okay, if there are no doubts, we'll move on to the next worksheet that's been distributed today. Okay, so while we wait for doubts, what we will do is we will move on to the next idea. See, originally the next idea was supposed to be tangents, but now we are going to have systems of circles. So this is part of SB3, which I hope you have seen already. Okay, so this is SB3, specifically 2 circles is what we are going to see. Okay, now just give me a moment. Okay, so we have some couple of doubts. Okay, first, Naitra Sujay has asked, I don't understand how cos theta by 2 is r by 2. Okay, so maybe what I should have done is to enlarge that image. Okay, because this looks too small. Okay, so Naitra, what is happening here is that this chord is subtending an angle theta 1. So this is theta 1. Now this is 2. So this is theta 1 by 2, and this distance CD is equal to R1. Why is CD equals R1? Because the radius of, so locus of all points is D, D1, D2, D3, etc. So this is D. So there could be a D1, there could be a D2. All of them will lie at the same distance from the center if they have to subtend the same angle. This is the big idea. So chords which subtend same angle at the center of the circle are equidistant from the circle. This is the theorem that you have learned in 9th standard. Equal chords subtend the same angle at the center. And this theorem is what we are using. Okay. There is one doubt which I did not check properly, where the doubt from Akshat Sharma is in question 9, isn't the length of the intercept okay? Oh, I didn't realize it could be more than one option right. If that is the case, I should have checked everything. I saw G squared is equal to C. Okay, I should have checked that. My bad, actually. I should have checked that. I thought it's one option right. And clearly G squared equals C was there. But if it's more than one option, see, x-intercept is 2 root G square minus C, which is 0 if in this particular case, because G squared equals C. Y-intercept is 2 root F square minus C. I didn't check. So Y-intercept is 2 root 9 minus 4 is 2 root 5. Okay. So that means this could have been a JEE advanced question. So this is correct. A is also correct. So those who wrote C for question 9 they are also correct. I see very few people. Most people picked only A, but I see a few people who picked C. Anushka Mathur, Then I see Advait Murthy, Akshat Sharma. You are right, Akshat. And a few others had picked option C, which is actually correct. Netra Venkata Subramaniam is also correct. Sri Raghav has asked again for the relationship between the locus and the r and theta. I explained it again. See, if you draw a circle slightly big, you find that r1 is this distance. So if you remove all these locus points, then it becomes easy to understand. The locus thing is to tell you that the radius of the circle, okay, so if you start from here, this angle is theta 1. So if this is r1, angle ACD is equal to theta 1 by 2. If you want, you can mark this as theta 1 by 2. And AC is equal to 2. So R1 is AC cos theta 1 by 2 is equal to 2 cos theta 1 by 2. So R2 will be 2 cos theta 2 by 2. If some other angle is being subtended, it will be some other thing. But all chords that subtend angle theta 1 will be at the same distance R1 from the center. That is why this is a theorem. Okay, but once you know that, then 2 cos theta 1 by 2 is R1. 2 is this radius, and cos theta 1 by 2 is cos of this angle. So that equals R1 in triangle CAD. I don't think anything else can be explained there. Okay, now Aditya Nanbu is asked, can we treat a circle to be part of a circle of infinite radius? I don't understand what your question is. If it's a finite circle, then it's a circle by itself. It's not part of any other circle. Okay, my general guess is no. You cannot treat one circle to be part of another circle. Okay, now for the systems of circles part, what I'm going to do is I'm going to quickly show you the animation that's there. Just give me a moment. Okay, so for positions of two circles, this is something that's included in your JEE main portion. So this is there in the skill builder. Okay, the common tangents part alone I'm not emphasizing. So let's say there are two circles which don't touch each other and that are outside. Now, what is the condition for two circles to be like this? If the circle 1 radius is R1 and circle 2 radius is R2, as you can see, then the distance C1, C2 must be bigger than R1 plus R2. If two circles are such that they don't cut or touch each other, the distance from one center to the other center must be greater than R1 plus R2. Now, on the other hand, if the circles touch each other, then C1, C2 must exactly be equals R1 plus R2. This is called touching each other externally. That is, the two circles are outside each other but just touching each other. Okay. Now, if the two circles cut each other at 2 points, then you can see that C1, C2, okay, this is R1, this is R2. R1 plus R2 will be bigger than C1, C2. So C1, C2 is less than R1 plus R2. Okay. But here, there is one extra condition that will come, which is C1, C2 must be greater than what of R1 minus R2. Why is this condition there? That I'm going to explain with the next thing. Because C1, C2 less than R1 plus R2, it's possible that the centers are very, very close. The centers are very, very close. What can happen is one circle can lie inside the other. And that is what we are going to see. Okay, here one circle is inside the other. In fact, it is just touching. And in this case, you have, this is R1 and the red thing is R2. So C1, C2 is mod of R1 minus R2. So if C1, C2 is so small that it is equal to the difference between the radii, then one circle will touch the other internally. So for the previous case, where the circles were cutting each other but not one inside, etc., C1, C2 has to be bigger than the difference between the radii, or absolute value difference, because we don't know which is bigger, R1 or R2. Okay. So this is absolute value of R1 minus R2 equals C1, C2. And finally, if one circle is completely inside, no touching, nothing, then C1, C2 is less than the difference between the radii. So you can see that summary is do not cut each other means, okay, the number of tangents part don't bother too much. Okay, number of tangents is 4. You can see, okay, that's there in your theory also, but somehow JE has removed it. But the condition we will write as C1, C2 greater than R1 plus R2. And the diagram is like this. Then touch each other externally. Okay, there are 3 common tangents. C1, C2 is R1 plus R2. And this is the diagram. Okay, cut each other at 2 points, 2 common tangents, 2 conditions, C1, C2 less than R1 plus R2, C1, C2 greater than mod of R1 minus R2, and the diagram is given. Then touch each other internally is 1 common tangent, C1, C2 is mod of R1 minus R2, and don't cut or touch, and one is inside the other. If there are no common tangents, and the condition is C1, C2 less than mod of R1 minus R2. So this is very, very important. If you did not do the skill builder, then I've given you a very quick 2-minute or rather 5-minute intro to the entire thing. Okay. Okay. So with this, you should now be able to proceed with problems in worksheet 2. Okay. So, and the conditions are also given here again. Okay, the number of common tangents part you ignore. It's just there for completion because it's there in the SB. Okay, 2 circles do not cut each other, do not cut or touch each other. C1, C2 is greater than R1 plus R2. That is, one is out, both are outside. Then equal to, less than, along with this is an extra condition that's very important. Then, so these are the different possible scenarios. Okay. So using this idea, you should be able to go ahead and do question 1 in worksheet 2. Okay. Okay, please go ahead and do question 1 in worksheet 2. Okay, a few people have solved it. Good. Okay, quite a few people have got this. Very good. It's a direct application of whatever I just told you. Okay, so first condition is C1, C2. Okay, so first let's write what is C1. C1 is -1, -2. C2 is 2, comma 2. I hope you're able to see. Now, so C1, C2 is root of 3 squared plus 4 squared. It is 5. Okay. R1 is R. R2 is root of 2 squared plus 2 squared minus 4, which is 2. So therefore, 5 less than R1, R plus 2, which means R is greater than 3. This is one equation. The other equation is C1, C2 is greater than mod of R1 minus R2. Therefore, phi is greater than mod of R minus 2. Okay. Now, R is greater than 3. R minus 2 is greater than 0, which means mod of R minus 2 is simply R minus 2. Therefore, phi is greater than R minus 2, which means R is less than 7. See, normally an equation like this will have two conditions. So, phi greater than R minus 2 or phi greater than minus R plus 2. Okay. This will give R greater than minus 3, which is useless because we anyway know R is positive. And here, in fact, r is greater than 3 is already there. So therefore, there is no point in considering this case. But in general, if it's not r, if it's some general variable, you might have to consider both cases. Here, it's not needed. Okay, so this condition alone is enough. So this is one inequality and another inequality. Sorry, not that one. So greater than 3 and less than 7. So the correct answer is 3 less than r less than 7, which happens to be option C, which many people have got as the right answer. Okay. See, strictly speaking, system of circles, like condition for one circle to be completely outside, cutting each other, etc. It is not listed specifically in the JE portions. But the last 2-3 years, after the cut and portions have been announced, these kind of questions have come, which is why we have included that explicitly here. Okay. So you can definitely expect, because they've removed all other portions related to tangent. So what else are you going to get, right? Anyway, your J is quite far, but I'm just telling you why we have included. Okay. Okay. Now, please go ahead and do question 2. Yeah, it's a little bit of calculation. As you can see, question 2, if you just look at it, you will know it's a JEE main question. But you don't have to get intimidated. I'll give you a couple of minutes, draw the diagram, do it systematically, you should be able to solve. Okay. Most important thing, don't get intimidated by the question. Okay, so it's been a few minutes already. So if you are stuck in this question, okay, so let me explain what's happening. Okay, so we have two circles. touching each other externally. Okay. I don't know the relative magnitude of the radii of the circles, but it doesn't matter. Okay, this is just a representative diagram. One is alpha beta, the other center is 8 comma 15 by 2. Okay, and this distance, so if you join them, this point is given to be 6 comma 6, and this is R2 and this is R1. So you can notice that, so let's call this center as A and this center as B, and the point where they touch each other as P. Okay, P divides AB in ratio 2:1. Okay, so clearly my diagram is wrong. So here you have to assume that AP is to PB is 2:1. Line segment joining the centers of the circle C1 and C2. Okay, so this is what you have to assume, in which case what will happen is, see, like that I said, the diagram shouldn't matter, but it might mislead you otherwise. So this is A alpha comma beta. This is R1. This is R2, and B is 8 comma 15 by 2. Okay. Like I said, it really doesn't matter how you draw, but sometimes people can get misled by the diagram. So AP is to PB is given as 2:1. Okay, hint is use section formula. You are given B, you are given P, so you should be able to find A using section formula. Okay, so if you have solved this question, good. And if you are still solving it, fine, not a problem. So I said use section formula. Okay, so P divides AB in the ratio 2:1. So therefore 6 is equal to 1 into alpha plus 2 into 8 by 1 plus 2. Okay, which gives alpha is 18 minus 16, which is 2. Again, 6 is equal to 1 into beta plus 2 into 15 by 2 by 1 plus 2, which gives beta is equal to 18 minus 15, which is 3. So alpha comma beta is 2 comma 3. Now we are ready to find R1. R1 is root of 6 minus 2 whole squared plus 6 minus 3 whole squared. Distance formula. So root of 4 squared plus 3 squared, which is 5. R2 is root of 2 squared plus root of 8 minus 6 whole squared plus 6 minus 15 by 2 whole squared, which is root of 2 squared plus 3 by 2 whole squared, which is root of 4 plus 9 by 4, which is 5 by 2. So we know alpha, we know beta, we know R1, we know R2. So all we have to do is just plug in the numbers. Alpha plus beta is 5. 4 into R1 squared plus R2 squared is 4 into 25 plus 25 by 4, which is 4 into 125 by 4, which happens to be 125. So alpha plus beta plus 4 into R1 squared plus R2 squared is 130. This is an integer. Oh no, not an integer, it's a multiple choice question. Okay. So let me pause here. We have done a couple of questions on systems of circles, okay, which I hope are not too difficult. Okay, if you have any doubts in either the theory, but don't ask me to do the entire theory again because it's there in the SB3 and I already did a summary and that's all. You can only ask clarification questions. Okay, or any doubts in the problems and the way I've solved them, feel free to post them or ask those doubts now. Let's take a short break for about 5 minutes and I'll be back. Okay, do ask your doubts. Okay, please come back. Please come back. Break is over. Please come back. Okay, first, let me address a question from Nilesh. Is tangents SB portion removed from CBSE or JE? If so, why are they still asking it in exams? See, tangents is anyway not there in CBSE. Tangents, which means equation of a tangent, at a point, from external point, etc., was in JE main. Now deleted. Now we've still given it as SB because it's part of the JE advanced portion. So that means you're expected to know later. Okay, but one thing is that even for JE main, NTA has not been very reliable. Okay, there are some portions which are not part of the thing, but it's been asked. For example, two circles cutting or touching each other. It's technically not in portions, but has been asked since 2023, 24, 25. Okay, all years have such questions, which is why I've included a lot of those questions here in spite of it being not in the portion. So whatever we are doing today, supposedly not there in the thing, but then see, the big problem with not specifying these things clearly and concretely is NTA can always say, look, you know equation of a circle. So if two circles touch each other, then C1, C2 must be equal to R1 plus R2. If they cut each other, then whatever. Right? So yeah, that is the unfortunate situation. Okay, now okay, only one other doubt. Vatsalya has asked, I didn't understand the C1, C2 with respect to mod of R1 minus R2 condition. See, what that says is that if, okay, so that is a slightly tricky thing, Vatsalya. See, if two circles are like this, okay, so you can see that, okay, so for example, this is C1, this is C2. Clearly C1, C2 is less than R1 plus R2. So that much is clear, no? Because this is R1 and this is R2. Okay, in fact, if you just, so clearly C1, C2 is less than R1 plus R2, but less than R1 plus R2 can mean many things. For example, a situation like this, okay, where okay, so the idea here is, so just think of how C1 and C2 will look here. So this is C1 and this is C2. So clearly C1, C2 less than R1 plus R2, but circles don't cut at 2 points. So this is necessary but not sufficient for two circles to cut at 2 points. So the second condition, therefore, is C1, C2 must be greater than the difference between the radii. In fact, if it's equal to the difference between the radii, then it will just touch. If it's greater than the difference, it has to go like this. And that's exactly what you want, cutting at 2 points. Okay, that's why this extra condition is there, Vatsalya. Okay, beyond this, you have to just go over the skill builder again. Okay, now J. Suryanarayana and a few others have asked, sir, what is a locus? Please say in simple words. Okay, I'm glad that somebody asked this question. Okay, see, locus means collection or a set of points. Okay, for example, a circle. Okay, selection of set of points. Sorry, I forgot this thing. Which satisfy a particular condition. So a circle, for example, is the set of points which satisfy the condition Cp is equal to R, where C is given. C is a fixed point, R is a real number greater than 0. So all points which satisfy this condition. That means what? If you put C, then you will get different points which all satisfy this condition. That so I can call them P1, P2, etc. This is P1, P2, P3, P4. All of them satisfy the condition Cp is equal to R. So if you collect all those points and plot them, what will you get? You will get a circle. In fact, circle is defined as the locus of points which obey Cp equals R. So locus means a set of points, not one point. Collection or a set of points that satisfy a particular condition. In that question 12 or 14, I don't remember now, okay, where there was a locus, okay, I think it was question 14. The locus of the midpoints of the chords of the circle means, okay, there is a given circle which has many chords. If you draw a chord and if its midpoint subtends angle θ1 at the center, then locus of those midpoints means find the set of all such points which satisfy the condition that the chord of which they are midpoint will subtend θ1 at the center. And that means it's a set of points, and that set is also a circle because it has a radius and a center. That's why it's a circle of radius R1. Okay, I hope this is clear. Okay, now let's go ahead and do question. We did question 1 and 2. We will do question 4. Okay, if you are stuck with this question, I mean, you don't need to draw a diagram exactly, but C1 is a circle in the third quadrant of radius 3 that touches both the axes. The only possible way for that is for the circle to be like this. Okay, and this means this distance is 3 and this is 3 and the center is minus 3 3. There is another circle with center 1 comma 3, and this touches the other circle, so this has to be okay, so this is how it's going to be. At the point alpha beta. Here, alpha beta is this point. Earlier, alpha beta was one of the centers of one of the circles, but here, okay, then you have to essentially find the value of alpha and beta. If you don't get intimidated, it's not too difficult a question. So let's say this is C1 and C2. So C1, C2 is R1 plus R2. So you have C1 is minus 3 comma 3, C2 is 1 comma 3, and R1 is 3. We don't know R2, but using this equation, you can find R2. Okay, so let's see. So we have C1, C2 is equal to root of 4 squared plus, sorry, this is minus 3 minus 3. I put minus 3 comma 3, that's obviously wrong, third quadrant. Okay, so 4 squared plus 6 squared, which is root of 16 plus 36, which is root 52. So R2 is root 52 minus 3. It's a little bit of an ugly expression, but I don't think it matters too much. Okay, now, so how do we find alpha beta? Okay, alpha beta divides C1 C2 in the ratio R1 is to R2. Okay, so you see alpha is minus 3 into R2 plus 1 into R1 by R1 plus R2, which happens to be root 52, which is minus 3 into root 52 plus 9 plus 3 Actually, if you keep R2 directly, might be easier. So 3 minus 3R2 by root 52. You can compute it later because the question is not asked to find alpha and beta separately. Okay, and beta is again the same logic, minus 3 into R2 plus 3 into R1. Which is 9 minus 3R2 by root 52. So the question is, you're asked to find beta minus alpha whole squared. 9 minus 3R2 minus 3 whole squared, and this thing cancels. So 6 squared by 52, which is 36 by 52, which happens to be 9 by 13. So that is m by n. Therefore, m plus n, which is what is asked, is 22. Okay, I hope this is clear. This is question 4. Okay. Go ahead and do question 5. Okay. A doubt has come from Sanjay. I don't understand what you did after you found R2. Actually, what I did, Sanjay, is see, I realized that alpha and beta are not separately asked. R2 is root 52 minus 3. To find alpha, alpha beta divides C1, C2 in the ratio R1 is to R2. Section formula. So you know C1, you know C2, we don't know alpha beta. Okay. So it is 3 into 1 plus R2 into minus 3. Okay. R1 is 3. So R1 is 3. So R2 is a little ugly. It's root 52 minus 3. This is what we found. But it turns out that you don't need to substitute this R2 at all, because this minus 3R2 will be there in alpha as well as in beta. So when you do beta minus alpha, it vanishes. If you were asked to find 3 alpha plus 5 beta whole square, etc., then you have to substitute, you'll get ugly answers. But here, beta minus alpha is asked for a reason, so that this root 52s that you will get in the numerator will vanish. So it will be simply 36 by 52, beta minus alpha whole square. That's what I did. R Sanjay. Okay, in question 5, if you are not able to understand what's happening, okay, in question 5, x squared plus y squared equals 9 is a circle that's given. We have another circle that has to pass through. It has to pass through 0, 0, 1, 0. 0, 0 is here. 1, 0 is here. And it has to touch x squared plus y squared is equal to 9. So the only way that can happen is if it's a circle like this. That is, it touches internally. I hope you are able to see how I've drawn. There are infinite circles that pass through 0, 0 and 1, 0. So this C1 is the origin, R1 is 3, C2 is H comma K, R2 we don't know. Okay, so you can see that okay, you have to figure out the value of 4 into H squared plus K squared. By the way, it says all possible values because your thing can also be like this. Okay, so we don't know what H and K are, but we know that the circle 2 has center H comma K. Circle 2 passes through 0, 0 and 1, 0. Now, okay, we know that R2 is therefore root of H squared plus K squared. Why? Because this is R2. But we also know C1, C2 is equal to, R2 is clearly smaller, R1 minus R2, which means root of H squared plus K squared is 3 minus root H squared plus K squared. Because C1 is the origin, C1, C2 is also root of H squared plus K squared. C1, C2 is the same as R2. So you get 2 root H squared plus K squared is equal to 3. So 4 into H squared plus K squared is 9. And that's what is asked. Directly, it's a two-step answer. The answer is 9. Now, in fact, it turns out that we don't have to use this fact at all. We are not using the idea that it passes through the point 1 comma 0 at all, because that means you'll get H minus 1 whole squared plus K squared, etc., which you don't need here. You're not asked to solve for H and K. You're only asked what is 4 into H squared plus K squared. See, that is the big idea in many of these questions. Okay. Now, after question 5, okay, let's move on to question. Okay, so let's move on to systems of circles where, okay, two ideas. Okay. First, the first idea, we don't know whether this is there in the portion, but I still want to do this. If you have two circles and you want circles that pass through the intersection of these two circles. So let's say two circles cut each other at A and B. Intersection of circle 1 and circle 2. So this is circle 1 and circle 2. Okay. Now, the interesting thing is there is not just one circle. Like for example, this is one such circle. A circle that passes through A and B. Okay. Then another circle that passes through A and B will be a circle that has AB as diameter. Another circle that passes through A and B will be this large circle. Okay, so all the green circles pass through A and B, and this means there are infinite such circles. Okay, please understand, this is all the ones that are all of the green circles are circles that pass through the intersection of circle 1 and circle 2. Now, you will think if you are given two circles, then you will find the points of intersection A and B, and then you can find infinite circles. But the thing is, beauty is, if you are given the circles as S1 and S2, there's a reason why we put it as S power 1 instead of S suffix 1, because S suffix 1 already has some other meaning. I think I told you last class. S1 is what you get when you substitute x1, y1 into the circle equation. Okay, if you don't remember that, go back and check SB1. Okay, so we put S superscript 1 and S superscript 2. It's not S power 1 and S power 2. There's no squaring here. Then the beauty is S1 plus lambda S2 equals 0 represents all such circles. Gives all circles passing through A and B for different values of lambda. So the beauty is, if you put lambda equals 3, you'll get one such circle. If you put lambda is equal to 29, you'll get another such circle. For infinite values of lambda, you'll get infinite circles. For every real lambda, you'll get one new circle. Except there is one situation, okay, where you won't get a circle. If lambda is minus 1, then S1 plus lambda S2 equals 0 does not give a circle, because x square will cancel, y square will cancel. Instead, it's a straight line, because it is of the form ax plus by plus c equals 0. And what straight line is that? That straight line is nothing but the common chord of both the circles. Okay, so so if I remove all the green ones, okay, okay, so this equation of the common chord is given by S1 minus S2 is 0. Remember what S1 and S2 are. S1 is x squared plus y squared plus 2g1x, where the center of S1 is minus g1 minus f1. S1 center minus g1 minus f1. Radius is root of g1 squared plus f1 squared minus c1. S2 center is minus g2 minus f2. R1, this is R2 is g2 squared plus f2 squared minus c2. Okay, the common chord AB is S1 minus S2 equals 0. And the other thing, that interesting thing is that the common chord is perpendicular to the line joining the centers. Okay, it's not very difficult to prove. Simple triangle congruence. AB perpendicular to C1, C2. Okay, this is also an important idea. And using these ideas, one can go ahead and do. Okay, so first let me ask you to do question 8. common chord of the circles divides the line joining their centers in what ratio? Okay, it's not a direct question of just finding the common chord, but it's also a little bit so here. If I ask you to find the common chords equation, it's very straightforward, it's very trivial. Okay, so instead what is asked is, what is the ratio in which it divides the line joining the okay, and that's a slightly interesting question. Okay, so you are asked, so if P is the midpoint of the common chord, C1P is to C2P is asked. So step 1, find equation of AB, and that should be fairly straightforward. Okay, and that happens to be 10x minus 6y plus 5 equals 0. You're simply doing S1 minus S2. Minus 6x plus 4y minus 4 is 0. So subtract like you subtract algebraic expressions, you will get 10x minus 6y plus 5 equals 0. So now step 2 is to find C1p and C2p. Okay, now here is a big idea. The common chord is perpendicular to the line joining the centers. Now that's a theorem that I have not given you, but that's something that you can easily prove using 9th standard coordinate congruence criteria. Okay, and the way to prove that, if you really want to know that, is first to prove, okay, triangle C1AC2 congruent to triangle C2A C1BC2 by SSS, because all three sides are equal. Okay, C1A and C1B are R1, C2A and C2B are R2. Therefore, angle AC1P is equal to angle BC1P. This is CPCT. Now also triangle AC1P congruent to triangle BC1P by SAS. Therefore, angle APC1 is equal to angle BPC1 is equal to 90 degrees. So if you want a proof, this is the idea. Proof for common chord is perpendicular to C1, C2. Okay, I hope this is clear. Okay, so that means if you just find the perpendicular distance from C1 to P and C, so C1 to AB and C2 to AB, that's enough. Okay, so C1P is perpendicular distance from C1 to AB. C1 is minus 2 comma 1 and C2 is 3 comma minus 2. So minus 2 to 1 is, so minus 20 minus 6 plus 5 by root 10 squared plus 6 squared. That is C1P, which happens to be modulus of that, of course, 21 by root 136. C2P is, C2 is 3 comma minus 2. 3 into 10 minus 6 into minus 2 plus 5 by root 136, which is 47 by root 136. So C1P is to C2P is 21 is to 47, which happens to be one of the options. Option B is the right answer. Quite a few people did get option B. Okay. Okay, the very last question that we will do is, because it's linked to this lambda idea, find the equation of the circle passing through minus 1 comma 2 and the points of intersection of these two circles. Okay, use the idea that S1 plus lambda S2 equals 0. Using the fact that circle passes through minus 1 comma 2. Okay, so that's the last question for the day that we are going to do. Nilesh P has asked, could you explain how you got the coordinates of C1 and C2? Of course, it's given in the equation, Nilesh P. If you are given the equation of the circle, you have to see, by now you should be familiar with this: x squared plus 2y squared plus 2gx plus 2fy plus c is 0. The center is minus g minus f. So it is 2 into 2 into x. So minus 2 comma 1 is the center. Okay. Oh, Hemant Aditya has asked a good question. How do we know whether to subtract S1 from S2 or S2 from S1 for finding common chord? Both are same. For example, in this particular case, if you had done S2 minus S1 minus X2, you would have got 6y minus 10x minus 5 equals 0. Is same equation as 10x minus 6y plus 5 equals 0. It's just multiplying by minus 1 because it's 0. That's why. Yes, Ashwin, in questions like 7, is it better to directly substitute the intersection point and eliminate some options and find the right answer by next clue? In question 7, we get option D as answer. Yes, if you feel like that is necessary, you can do. Okay. Okay, question 7, a few people have answered. I think the answer box was not posted. Okay, that's okay. So equation of required circle is x squared plus y squared minus 2x minus 4y minus 2 plus lambda times x squared plus y squared minus 9 is 0. So I said it's S1 plus lambda S2. Just to give you this notion that when lambda is minus 1, it is common chord, right? Now we are told that minus 1 comma 2 lies on required circle. So 1 plus 4 plus 2 minus 8 minus 2 plus lambda into 1 plus 4 minus 9 is 0. So this becomes minus 3 plus 4 lambda is is equal to 0. Lambda is going to be, sorry, not plus 4 lambda, minus 4 lambda. Lambda is minus 3 by 4. And when you substitute minus 3 by 4, you get the required equation minus 3 by 4 into x squared plus y squared minus 9. So 4x squared minus 3x squared is x squared plus y squared. Okay, so in fact, you can write this as 4x squared plus 4y squared minus 8x minus 16y minus 8 minus 3x squared plus 3y squared minus 27 is 0. So you get beautifully directly x squared plus y squared minus 8x minus 16y minus 8 plus 27 is plus 19 equals 0, which is option D. Okay, which quite a few people have got, and somebody asked, like, can you just check 1 comma minus 1 comma 2 and find the answer? Yes, you can do that also. So let's stop here. Okay. Okay, so let's stop here, and we'll probably just start the test in a couple of minutes. Mentors, you can go ahead and start the test in a couple of minutes. Okay, good luck with the test. Okay, I'm sure you will do well. Okay, and do finish. We will continue next class also with circles. Okay, because there are more questions to be done. Okay, do finish SB1 and SB3 definitely before next class. Okay, good night, and I will see you next week. Bye-bye.